Hello, my name is Stephen Grillo. I am producing this video in order to support a proposition that I think needs a thorough airing. Now, this proposition is really an outgrowth of a deeper examination that has been developed along the way. This will be a quick survey of how a slightly different emphasis can be placed on some otherwise very well-known propositions that we carry in space physics. We can begin very simply, and at a very unassuming juncture, we shall have passed into a set of larger issues. So, we begin. I hail from Texas, and in Texas, it's not uncommon to find yourself out in the wilds doing a bit of plinking. Plinking is just firing a varmint rifle at whatever target's available. And so just imagine here we're plinking and we're just watching what happens as a rifle bullet passes straight away from us and counters the target. Very simple, what we understand very clearly. You might notice the bullet is traveling along this reference line as it should. It's traveling a straight line as we would understand it. So it so happens that as we plink, we're we're really firing across a levee, and on the levee is a little rail car carrying coal, let's say. And as we plink, this open coal car passes, and the bullet goes right through the open door and continues on to the target, like so. Now we complicate matters just a tiny bit. There's a there's a coal tender on the coal car, and as he sees the target, he decides he will fire a pistol at the same target. And what we will see as he does that is something a little interesting. But take note of what we're really going to show here first. We're going to show that as he fires his bullet, it sort of flies out into space, but stays relatively right in front of his barrel. In other words, what we know is the bullet has the same inertia as the rail car, the frame of the rail car, and so it's traveling out into space as if it belongs, as it were, right in front of the barrel of the pistol. So this is the phenomena you see. Looking straight out the barrel of the pistol, we see the bullet flying away as if it has only one natural behavior, which is to fly straight away from the barrel of the pistol. But notice all the straight lines the bullet seems to cross, is 1 and 2 and 3 and so on. As it goes down the track, it will continue to fade off into the distance, crossing these lines. And now we're going to just get a slightly better bird's eye view of exactly what this set of elements actually present to us. Just another view. Now we're going to see the bullet leave the barrel. There it goes out to the frame. And as we would expect, it's traveling with the inertia of the frame, traveling from where it was loosed, right above where the rifle bullet came through, because he was firing at the target when it happened. But the bullet has its own inertial issues to deal with, and not the intent of the coal tender firing at a target. It's going to travel, as we noticed, across these lines at an angle. And if there was no gravity or air resistance, it would do that, well, for quite a long time. But it would always stay, as we can sort of infer here, straight in front of the barrel as it exited and continued on downrange. So we've looked at 2 or 3 simple scenarios that involve inertia of a projectile and the standard understanding of a projectile that's just traveling without that given inertia. But now we're going to complicate the scene just a little bit, but it will require almost nothing else of serious thinking. But what we're going to do is we're going to discard the pistol bullet completely and concentrate instead on the radiation flash that comes from all the exploding propellant that comes out of the barrel. And what we see when we see that is a little bit different scenario, but we see this. We see of course, radiation in this case, we're slowing it way down to give us just a grasping look at how the general behavior really does fall out. So the bullet continues on, the rifle bullet continues on down its track. We've discarded the pistol bullet, but we notice the barrel of the pistol, and we notice that it continues on with the given inertia that it has, moving down the cold track here. So it's down here now. The bullet's on its way to its target. But notice what we can already see here. The radiation left the point in space where the explosion happened. And if you actually look closely here, I'm actually moving the Earth plane itself to give you another instance of regarding this particular proposition. The proposition is that for all the frames that are moving, notice the frame moving, the Earth frame, this coordinate frame, it's moving, and yet the bullet seems to stay right on track because now the rifle bullet has its own inertia. It has the inertia of Earth. And so it stays, as did the pistol bullet stay out in front of the barrel. We watched that happen. Now the rifle bullet is staying on the same track as the purported rifle, which is, let's say, here, and fired it, and it moves downrange. Notice the coordinate system is moving as we do this, and it still contacts the target because the target's also moving on the same frame and coordinate system of the Earth as it moves. So we have a relatively faster moving frame with the gun barrel, and we have a slower moving frame with respect to the Earth, but we have the telling argument to be made that all of the radiation doesn't have anything to do with, or let's say be concerned in any physical way with the behavior of these frames. Especially, we say, the inertia of these frames has no real bearing on the behavior of the radiation as it escapes, once it's generated in space, as it escapes a given and unique space point. So all the distances to the edge of the sphere here are the same. And most importantly, and let's back this up just a little bit to give you a little bit of a closer idea of what we're saying here. If we had a mirror placed on the tangency of this sphere and bounced the light beam back, even as the rest of the sphere continues to grow out, this light beam would be coming back. And it would be coming back straight to the spatial point of the origin, and of course not back to the barrel from which the flash actually emitted. There's no standard geometric logic to putting a line of tangency here, reflecting the light straight back on its own path, and then having it come back through this origin. Well, there's just no reference of logic that puts it back to the barrel, you see? And we're trying to make now this subtle point have a great deal more weight than sometimes it is given. We are seeing that a space point is a unique, discrete reality for the radiation. And it has a casual association with the given frames, because at a given instant, the frame was at this point and the emission of the radiation occurred at this point, and the two separated instantly from that space point. The radiation left and the frame left. And at this point, they are not connected. That's just it. They are not connected. Yes, the radiation can be said to illuminate the frame. If you want to just get into the general overt technicalities, yes. Overtly, the radiation would illuminate the frame. But that's it. The radiation only knows this unique origin point in space from which its history will evolve. And here we bring in the larger argument. Here we bring in that at this instant, the inverse square law, which controls how this radiation will fall off, but perfectly away from this origin point, well, the inverse square law becomes a proxy for this origin, this unique origin point in space for this particular emission. So we've done well, at least a casual mathematical tenet was constructed when I said what I just said. The radiation expanding into space at one velocity, c, creates a proxy for the origin of that radiation. At the emission point of that radiation is a space point. And so the emission is a real, concrete, and fixed event, and it occurred at a space point that is also real and concrete. And the radiation that falls off in every direction, as it were, is indicating as a proxy that exactly that phenomena happened at exactly that space point. Now, of course, hooray, we can get into the mire very quickly now, can't we? Because who's going to mark that space point? I mean, in any other frame-oriented or referentially constructed form? Well, nobody. Nobody's going to mark that point. This, as we will jump forward now just a little too much, but this is one of Einstein's key issues that he will use in relative rest, is that nobody can mark this point that would be, as it were, outside of this frame that's moving along here. He keeps all of the logic of his reason inside the frame. And we will say, in a moment, we're going to look at something Einstein has done and wonder just exactly how it is really and truly all supposed to resolve itself if this simple scenario is true, and if the mathematical tenet we just constructed is that the radiation itself is a proxy for an otherwise unmarkable point, then we have something to at least produce some interesting conjectures, I feel. But it's that simple. It took us just 2 or 3 little episodes of the most rudimentary pieces of behavior, and now we're all the way into Einstein and wondering whether or not his completely enclosed frame dynamical arguments totally construct themselves in a universe where this kind of proxy that doesn't seem to have impressed him much indicates that there's an origin to specifically the radiation that's moving through space. And so if that has not been too difficult a wrangling of ideas and issues, we can look very interestingly at, or we can at least say that this, as a mathematical conjecture, is easy. This is easy math to create a tenet based on this kind of reasoning. It's easy. Anybody can do it. The trick is, does this map down to reality? Would reality support the fact that the proxy of this radiation fall off indicates strongly, concretely, that there's a unique space point? Even as we go in some other technical in empirical valuations, we can't mark the point, but the point presents itself as a utility function if we consider the roll-off of the radiation as its main proxy. Now, to bring us back to the scenario that we just examined, we're just going to look now at the radiation from a little different perspective. We watch the rifle bullet and the frame of Earth as we see it here moving this to the left, and the frame moving even faster, so the barrel is moving on at its own rate, and the frame of Earth is moving on at its own rate. And the radiation, of course, is only concerned with its spatial route. It's the space point from which it emitted. And we watch then as the Earth frame allows the rifle bullet, to travel on downrange, always seeming to stay on this line, but it veers away from the point in space where it was when the flash occurred. If this is where it was, that's just a space point marker, and this is a space point marker for the radiation. And so we see how it has traveled in its own inertial path with the frame of Earth to very handily land at the target, as it also is moving with Earth and down so far downrange. So there it is, a simple way of looking at two different motions with two different vectors per se, neither one having any effect on the radiation evolving away from the space point where the emission occurred. So that's just a helpful perspective, I think. And again, so far, I'm quite certain we understand this to all be true. The exact tenet I'm trying to construct, where the radiation fall off is a proxy for this space point, that's purely mathematical, an easy mathematical conjecture. But as I might be able to ask you now, tell me how it doesn't map onto reality as we know it. Because the energy leaving this flash is going to carry what tiny particles of energy and value of energy right on this bubble. And it's going to end up at Mars or wherever else when it gets there, carrying its almost nothing energy. But still, this is where it started. And it carries that energy and all of this energy in all the different directions that the light slash radiation will uh, manifest as it moves through space. So it's, again, we're saying this is how this proxy, this radiation emitting from one point in space itself, with all other frames of reference notwithstanding, it is the actual medium by which energy is moving, or it's the function. The inverse square law is the function by which all this radiation runs off into all its various directions through space. And that's just, again, an overt way of saying that this should, by all reckoning, map onto reality as we know it. But just for the sake of what we're about to experience, we can say that, well, it's just a tenet for this particular bit of analysis concerning these frames. Very simple, I think. But what I have conjectured here is, again, if it maps onto reality, it's very serious and carries a lot of implied meaning. And we'll try to get to that now. So we find ourselves with this bit of a proposition that the inverse square law has some value to frames that are moving. Doesn't matter which of their vector values they obtain. The space point that serves as the emission point is in control of the inverse square law that the radiation falls away from, and is again what we call what we have always termed as the value of the inverse square law. So here we look at what Einstein's train paradox is illustrating for his concept of simultaneity, as it were, and it's often considered non-simultaneity, but it has to do with the fact that a given, what seems to be a singular event, can be interpreted two different ways. I'm going to just read what's here because it helps structurize what we will talk about following. Lightning strikes the front and back end of a moving train, leaving char marks on both tracks and train. So now at this instant, we're charring both the train track and the train, or two different rail cars, as it were. Now, moving is the key point. Each emitted flash spreads out in all directions, just as we were just talking about, by virtue of the inverse square law. I think so, but let's stay with the rigidity of this reasoning here. Center panel. Observer riding in the middle of the train concludes that the two strikes are not simultaneous. Now, to just jump ahead, we see that this individual being right here in the midpoint, we'll see them as simultaneous, but we're stepping through the argument as it's presented here. She will see them as not simultaneous. Indeed, as we see here, this first contact is happening near the, I guess, the leading edge of the train, and the strike and the char. Here's the char point. This point is actually on the char point of the track itself. So this is a char point on her train. They are not simultaneously. Going back here. Her argument. I am equidistant from the front and back char marks on the train. And she is. There's this distance, and there's this distance. Light has the standard speed in my frame and equal speed in both directions. I submit to you that that's a tenet. That's a conjecture. That's what Einstein's relative rest will have us understand. So we continue on. The flash arrived from the front of the train first. Therefore, the flash must have left the front of the train first. The front lightning bolt fell before the rear lightning bolt fell. I conclude that the lightning strikes were not simultaneous. Of course, the bottom frame is just he's halfway between each one, and he sees them very much simultaneous. So here's two lightning strikes considered non-simultaneous by one observer and simultaneous by another. That's the paradox involved here. Now notice very carefully that the analytics of this center reasoning here, this reasoning that they will, again, light has a standard speed in my frame and equal speed in both directions. The flash arrived from the front first. Well, that's true in all analytical cases. See, the pure analytics that we understand. See, for him, he noticed that she was there when the lightning strike got to her, and it's going to take a little time yet for it to come on to him. So analytics is from his point of view, is understanding everything very carefully, or very simply, very simple. And then in the next instant, he experiences both, and now we have to understand, inferred not in this particular diagram, but this pulse will then overtake, continue past this observer, and then as this observer is further down here, this pulse will overtake and connect here. That's the second flash as this onboard observer sees it. Now, let's just jump in this for a second and try to be this observer on the train. And let's just say it's all closed up, because that's one of the special confusers that are in this case. But if all she saw was a little spot, a little hole on each end of her rail car, well, assume she could see all the front and the back clearly through just little pinholes where the lightning comes in. Sure enough, the front lightning strike would impact this observer first, and the second would be would impact, connection would happen as the observer moves on. Again, the observer is moving, but the whole point of Einstein's standard speed in my frame equals speed in both directions. This person is in relative rest because of the uniform motion. What Einstein is doing is discounting the motion. That's what he's doing. And if you're there and just kind of blindly seeing what's going on, yes, you see this strike first and then this strike later down the range. Two different strikes. Well, obviously. But that's because you are at relative rest and you can then say, aha, this point, this lightning strike happened after this lightning strike because I perceive them as such. And here's your major point, is because the motion you are actually exhibiting cannot be measured by you. It cannot be it cannot be certified by you, and therefore it's not meaningful to you. And so said observer sees two different pinpricks of light at the end of his train cars. One occurs and then the other. And the motion that is inherent, which causes these separations of contact, has to be discounted. And the imprimatur that then is valuable is the simple, almost shrug your shoulders to the idea that it has traveled from this char mark to me and this char mark to me. That L1 and L2, light has to have traveled through those inviolately. That's how relative rest works. It has to have traveled inviolately. And so I am seeing two different strikes happening at two different times in my worldview. I have a different worldview than you because of my motion, but the most important point that I have to make is that I cannot count my motion. My motion is not valid. This observer, is at relative rest. And so, again, in the pure analytics that are trying to underwrite all of this, we can see, just as this observer could see, that by definition, he sees a motion, he sees the motion. And so this first contact and then this later contact down here makes perfect sense to him because, well, it's what light's doing in space. This person is blind to all that. That's what Einstein would say. You see the pulses in both out of time in your frame of reference. Well, they're out of time. It's two different temporal realities for you in your frame. And that, then, my friends, is where we can make, I think, a telling statement, because now we're about to see the value of what the inverse square law has to say about this. Because in the scenario, these two lightning strikes are presumed to have equal intensities. In other surveys, you look at this, that's kind of the given. They're at the same intensity. They're identical. Let's just say they're identical strikes, but at two different points. So if they're identical, they have the same radiant energy emitting from them. Just go that way with it. Which means what? To this guy. Well, to this guy, it makes perfect sense that the radiation will hit this observer first, coming from this, well, inverse square law, telling from his point of view, that's the char mark that counts. In our point of view, it's at least symbolically where the space point is where the radiation occurred. So now that radiation will leave this point, not this point, and to satisfy first order analytics, occur to this person on board first. So far we've got a very clean analytical structure, but this person is in its own universe And the meaningful thing is this char mark over here. This is outside of the frame, as we have made a point of earlier. This is an unmarkable point in space for this observer. And so, as we just stated, that the identical strikes, or the lightning strikes were identical, it gives us a real problem to work with right here. Because though in overt terms, and to be analytically balanced, it's true. This lightning strike happens first to this observer. And so far, so good. The relative rest argument is holding up. And then a bit later, this pulse coming along will intersect the observer somewhere down over here, and that will be the second strike in that person's timeline. But that person, again, will only concern itself as an observer with the char mark on the train, not the char mark on the track. But as we are saying, the char marker on the track is symbolically the spatial point. See, this is what I'm saying. This is what I'm trying to say. Einstein rejects everything outside of the lab, and the frame here is the lab. So for him, the only point to be observed is this point to here, and this point to here, and it came at the same rate across that point because you're at relative rest. So goes his tenets. But why? Why would you accept that? Because it seems clearly to everyone else involved. There's as Einstein said. Well, you're everybody else is involved is it's some absolute perfect value of observation, which you don't have in real time in real physics. He's saying all you have are these points, the points that give you reference in your own frame. Okay, not bad, but still we see the problem, or I think you're at least seeing what I think a real world problem is. And the real world problem is that the radiation, when it finally intersects over here, is much further along in the inverse square law roll-off. And by dint of equal reasoning, the radiation that left this char mark, and she encounters first because her motion is real to that char mark, and that's why she sees it as real. That's a brighter stroke of lightning, though we're giving the argument that they are identical. So the radiation strikes are of unequal intensity, and that's the problem if they are identical lightning strikes happening at two different times. If that were true, then the intensity that would be witnessed by the observer would be identical. And now I ask you to think hard. Would they be? Would they be? Given that you think, as I do, and we looked earlier, that the inverse square law began here, and the reason there was a second strike is because it left from here and traveled to here, even as the observer traveled from here, let's say, to here. The motions count for the inverse square law. The frames count nothing towards the actual space point of origin of the radiation. So this is meaningless. This is meaningless. This means everything. This means everything. And of course, in our earlier example, we already showed how those are on the Earth and they're moving away from the radiation point. So those are proxies for the space points, even in this simple example. But we notice how even if this observer is moving, we could still have the reality that we're looking for, which is simultaneity here, and given this person's extra velocity, a non-simultaneity here. But the inverse square law is, again, just trying to root it in this simple scenario here. It's equal to this individual, and it's equal to this individual from here and here. But this individual is at two different locales with respect to the very real, finite, linear definition of the inverse square law. So from here to here is why it's taken her, this observer, to see it come as a second strike. And to go from here to here is why that observer could see it as a first strike. But what we're screaming is, yes, if all you want to do is count the pulses and demand that they travel from the char marks from here to there, just in some postulate construct, then you're just ignoring completely what the inverse square law actually has to say about what this person's limitations are. If this person, and here's the proposition I started with, if the proposition is this, if this person has a two-sided luminosity gauge, when this face of the luminosity gauge connects with this pulse, it's going to give a higher reading than when that same luminosity gauge it finally catches the pulse that's moving here, here, and then finally here to her. It's rolled off. Its energy density is less. And so, all things given, the postulate fails because she does not, in other words, because this observer does not see identical radiation readings, they are not merely out of time. They are not merely out of time because in relative rest, if they were merely out of time, they would have crossed the L of this and delivered the same intensity, and then the L of this and delivered the same intensity. But that won't happen in this real world construct. So this is a real world construct that we're trying to inject a postulate construct or a tenet on top of. And we're trying to say, wouldn't it be interesting if we held true the basic argument of the inverse square law and said that, well, the reason this is the second strike is because it took longer to move through space to get to that observer. And this is the first strike because it's oriented and only travels this distance as the, see, this is straight up analytics now, simple analytics. Einstein says very cleverly, and we might even have to still tip our hat, but he says that this observer can't know anything about these external points and references in space. They can't really exist. Wow. There we go. He's a winner in that regard, except that his case still falls apart because this individual would get two different readings. Now, that person would have to know that identical strikes occurred, which is not easy to do. So that's a bit of an open question. But assuming that that knowledge is available, then we have a case. We have that case, well, they're supposed to be identical, but my luminosity gauge reads them as unequal, even though they have traveled, knock, knock, across the same identical length of my frame. It's gone from here to here to me, and it's gone from here to here to me. But they're unequal, though they started out so. Is it possible that there is some motion that's real to the entire back structure of all of this that is meaningful, and me closed in here, I can't see it. Me trapped in relative rest, I can't see it until I establish a two-sided luminosity gauge, which takes the simple inputs and outputs of the contacts, the simple time rate contacts that are part of the analytics here that we can see very obviously. This is all analytics operating. It's just the postulate is that this person's at relative rest and can't know it, or can't know anything about the motion. And so there it is. I propose, seriously as I can, by dint of this reasoning, if the inverse square law can be said to have some bearing on the timing sequences, which is what Einstein accepts as real, he just forgets completely that the roll-off of the radiation has something else to say about his postulate. And they say, oh yeah, well, you could presume they came from the front and the back char marks and hold yourself at relative rest and get these two different strikes, and then back channel your reasoning to say, well, it went this distance and then this distance. That's the only two distances that apply to me in my frame. And so light's constant in that, and that's just all postulated. That's all a postulate. It's just constructed. It's just constructed at this point. And so you can accept it if you like, I suppose. I mean, you can. I mean, again, if you're in that frame without a two-sided luminosity gauge, you will see one strike first and then second strike second. You won't really know the tiny difference in the radiation. And so you will say, these did not happen simultaneous. And by very overt terms, you would be correct. That would not be simultaneous. And then if you just stand there for the next microsecond and go ahead and accept relative rest, you will say, the char mark at this end and the char mark at that end are exactly the same distance away from me, and I hold C to be C in all frames, then it crossed the frame in identical speeds. See, there it is. That's the conjecture. It crossed that frame, that moving frame, at the same speed. That's what she has to use as our analytical tool. She's left to use that as an analytical tool, and as an analytical tool, the world view has to change. The world view is they happen non-simultaneously. But there is, again, a fragment that seems to have been overlooked, and that fragment is telling you that all you got to do is just look at this in terms of the radiation fall off, and a two-sided luminosity gauge would tell you that. And the case for Einstein's poor observer here being very lost in relative rest sort of dissipates. I don't think in fact, it's very strong at all. But now, all a person can do is consider this and construct this in his mind, like a Gedanken. This is one of Einstein's Gedanken experiments. Assuming the blindness of the observer here, he's kind of got a point. But not if we that understand the universe square law, and that in practice, in reality, this observer could have a luminosity gauge. And that tool to help extend the depth of the analysis would tell Einstein that he can't make this assumption that it's just these char marks that have any meaning on the frame. As we said earlier, as frames move away from the emission points, that has nothing to do with how the radiation will fall off at C. And so there's my proposition. It's mainly right here. It's for anyone that will sit down and now think the experiment through as many times as you'd like and see what you'd like to see. And see if not, you would have to end up holding that the non-markable points, like I said, this is the char mark that we already said earlier could be moving with the Earth. So the true, if the Earth is moving this way too, well, the true origin of the space point is really over here. So the radiation even fell off further than this distance, but that's a smaller point inside this larger point. If the motion of Earth was true, then this guy would also see slightly different out of time sequences, and the simultaneity is just a thing that can happen in a very, very limited context. That limited context would be this observer is fixed in the frame of space. In the frame of space, the inverse square law is meaningful. It holds that this guy could be this way. But again, this is the two different frame velocities we looked at earlier that still have nothing to do with the inverse square law and its emission point in space being localized by a unique point in space. Unique space points control the inverse square law. Does that map onto reality or not? That's the overt conjecture. Mathematically, I think we see it very easily, very simply. Now, would a person be in violation of all scientific reasoning to just reconsider this and then think, well, does it? Does the inverse square law and the radiation serve as a proxy for a space point that's real, that served as its true locus? And all the frames moving away from that true locus in space, well, they will just experience what they experience. You have to be clever to find out what's maybe really going on. And I just proposed that. a two-sided luminosity gauge will do what Einstein says cannot be done, which is to experience some reasonable analytical data that suggests one thing if you know that they were identical strikes. In other words, you're forced backwards into, well, maybe I'm moving. Maybe I've moved with respect to these space points. And maybe that's why I've seen differential outcome from my, well, see, now we're back on an analytical path that's very interesting. And so this, I suppose, sort of rests the case. Now, what we can do is finish up with just a few examples of what is also very interesting to just review in this context. So we can show easily what Einstein's argument presents for us, even as we set it up to put another blast at one end of the frame that's identical to the blast that's going to happen when the pistol goes off. So this is a scenario. We kind of cut a section out, but now we'll just see what we've just discussed. We will see the bloom occur both ends of the frame is the first instance, and then lo and behold, the observer, now moving kind of to the left in this particular scenario, encounters this blast wave first, as that observer should, and then in a bit of a trice later, the second bloom encounters the observer. So two different strikes for this observer. And that's just a simple way to see what we just looked at in a sort of a flat discussion with a graphic. We're doing a little animation here that helps reveal all the essential basic truths. Then, as we say it, it's the blast wave away from a space point that's the important takeaway. One, two. And of course, the wave fronts, as it were, the blooms, are identical because they were created identically at the same time, and they bloom through space identically. And just to illustrate the point from a different perspective, we see the frame moving of Earth, and we see the faster moving coal train moving, and we see that right about here, this observer sees both of them as simultaneous, even though clearly the observer on the moving train sees this one first. That's contact point one for that observer, and then this is contact point two for that observer. So two different contact points for the moving observer on the train inside the frame, and then simultaneous contact here from both pulses. And now I'm going to try to illustrate what it looks like if we do exactly what Einstein says is true for the relative observer. We're going to try to make the light move through the two distinct L. This is let's just say that's L1 from here to there, and L2 from here to there. And we're going to see that the radiation will now travel in equal times to the observer. And watch what this looks like. What's going to happen then, of course, and you can see it's happening, one radiation bloom has to be different than the other. See, this would be then the counter-conjectural proof that Einstein's argument's not true about the internal observer, because what I've done literally is slow the speed of light down from here to here, and I've increased it from here to here. This is C minus X, and this is C this bloom is c plus x and this is c minus x. So altering the speed of light within the frame is the only thing you can do to get it to occur that this, I'm just solving his tenet, that both have traveled through the same distance of the frame at the same rate. This is the same rate with respect to a moving frame, but it has to include the frame's velocity to get rid of it. We're tearing out, as it were, the velocity of the frame by adding it to one bloom and subtracting it from another. And that's clearly, as it were, illogical. Now, you'd also see, though, that this observer, when that is true, when the light has moved at the same velocity through the frame from both L1 and L2, well, the strikes then would be simultaneous. But again, with the same luminosity gauge, though simultaneous, the radiation density is different for both of these, given that they've bloomed at different rates. This one has, by definition, not bloomed as much as this one has. So its density is higher on this side than it is on this side. But of course, it's a canard. That it's true, again, in the simple way you can make a mathematical argument be true. You have to do this and this to the speed of light given each bloom. And now you have something that's actually true for this observer. Oh, the light traveled in equal times from the char mark to me. Again, still ignoring the origins of space, but as far as the char mark's concerned, this is how light would arrive, traveling at the speed that tears out the motion of the frame. And of course, they would be simultaneous. But you can't cheat the inverse square law. You can cheat the speed of light, and so you're cheating the simple time rate problem and getting a simultaneity that's both true, that it's most true that it's a simultaneous event, but it's also true that it's crossed the frame in the same amount of time. So we see what would be required, because what we see, if we just look at it closely, the radiation is moving through the frame at an equal rate. Given that the frame is moving, you have to alter the speed of light. But it's also true that it's taken exactly the same amount of time for those radiation blooms to occur. And so by another dint of simple mathematical recognition, you could say, hey, they travel through this frame at the same rate, and they shall have, and the equal times, therefore, from one char mark to the other. But you're not dealing with the uniform velocity of light now, which is what the true radiation bloom would indicate. And so this is just another way to visualize the incongruity that the onboard observer is trying to see these two strikes now with the rule that it has taken equal time for both of these signals to get to that observer. And now you see the only way it can be true. And it dislocates the mind pretty easily, doesn't it? And so this is what I would leave for you to consider, that the equal time construct has been met. That equal time construct also indicates that they are simultaneous. But the inverse square law is also telling you that there's a discontinuity in the readings. And so you still have a way to say something's wrong with the analysis if somehow you're trying to assume that light is moving at a different speed through the frame just to satisfy that each now has been traveled the equal time. Well, it's true, but the strikes are not non-simultaneous. They're simultaneous. And so as light moves through that frame in equal times, you see the simultaneity. I said equal times. Einstein just says, oh, but it's also the same rate, and you can't have both. That's what we're trying to say here. You can't have both. It can't have traveled through the frame at one rate and then discard the entire structure of the other spatial elements and then just say, oh, well, of course, that happens in my worldview. In my worldview, these things have happened at two different times. You alter the temporal construct, I guess, because it's the most plastic. Would that be it? It's just plastic enough to change without trying to understand other things that are trying to present themselves? I don't know. So for me, this conjecture stands. I think a two-sided interferometer will, if a person thinks hard enough, you could do it in your as an exercise in your own brain. I've given you all that I can. I've shown the discontinuity that is required if you want light to have traveled at the same speed from char mark to observer. Well, you have to change the speed of light inherently. You can't. All I did do, though, listen carefully if you want to get a little bit lost, it did happen in the same time. It took equal time for those light pulses to get to the observer. Now, is equal time equal to the same rate? Well, no. You could continue to parse and use analytical tools to get a different and deeper meaning. The only thing that satisfies the equal time scenario with a moving frame is if, given that you're trying to get an equal time for a given L or two specific equal lengths of L, then you have to change the speed of light to offset the speed. You have to change the speed of light in two different ways. That's the key. And then you see other parts of the analytical surface, the analytical scenario surface. In other words, you see the simultaneity, and you have the other equal times that they have crossed the frame, but you still see a different bloom. You still see a disordinate bloom, which will still give you, even in as a quasi logical argument to change the speeds, you would probably still be able to see the same luminosity gauge giving you disparate information. So something is wrong with your conjecture. So if you could do this in your mind, I've given you the visual tools to do it in your mind, you could still say, but the inverse square law is still operating here. And we have different densities of energy. So something is wrong with changing the speeds just to give us equal times to have crossed from char mark to center. And so all of this discussion ensued when I asked you to do one simple thing, which is get rid of the bullet and consider only the flash, which is what we did here in this first, like second or third, I think the fifth panel. And the fifth panel is where it all starts. Either this is valid, not merely as math, but as mappable onto the physical universe that we work in. And if this is true, and seems so obviously true as we look at it here, but can map down onto the same reality that Einstein's trying to make his relativistic, his relative rest case work for an observer on a train, then you can see how this simple notion that radiation leaves a space point and the frames don't matter until you understand exactly what the frames have to be doing. And so I say the two-sided luminosity gauge may not be the perfect tool to give you exact kind of data to work with and find out your own velocity, but in ideal terms it could. I'm just saying that overtly it would show you something's wrong with Einstein's case, because an onboard observer that does experience what is spatially two simultaneous strikes with respect to some coordinate system, the motion of that frame that the observer's in has to actually obey the space points and not the scorch marks on the frame. The two-sided luminosity gauge will present you with that conundrum, and perhaps a little bit greater light, no pun intended, a greater bit of light thrown into his relative rest frame. And indeed, other arguments like this involving Michelson's error are part of this larger assay. Thank you.